So you want to charge your Model S off-grid. What do you do? Well, your options are extraordinarily limited. Being that the Tesla vehicles, specifically the Model S, well, they only got 2 models, are very finicky about the type of input power, whether it be poor ground connection or dirty power. If you don't have a clean, stable power source with a working ground, you're pretty much dead in the water. So I'm just going to go over a few options right now. We have a inverter generator. I have 2 different power inverters we're going to test. Now, this inverter generator, it's somewhat of a copy of the Honda, the new Honda, was it EQs? Or is this an EQ? Something like that. Honda, I think it's EQ. This one's made by ETQ, if I'm reading their poor label correctly. This one's a 2-stroke instead of a 4. The next version up from this one is a 4-stroke. That one does 2,000 watts. This one does 1,000 watts. It was cheap. They're about $180, free shipping. They're not nearly as quiet. One of the Honda inverter generators, you could be standing next to and barely even tell it's running. That's how quiet those are. Whereas this, it is noisier. I haven't found any quieter than the Hondas. I'm hoping to be able to test a Model S with one of the Honda ones within the next couple of days at a friend's house. I still got to ask him and see if it works with his generator. So first, alright, there's the UMC. I have a Vector 4600 power inverter. Now that one is actually rather old. That one's about 14 years old, and it was expensive. It's only 600 watts. I'm not going to actually be able to charge the car off of that one if it does work, because it is 600 watts, which is less power than the model. Distraction of the day. 600 watts is less than the Model S draws at its absolute lowest amperage setting, but I'll still be able to plug the UMC. Right? So for the most part, if the UMC flashes the naughty colors and won't let us charge, it doesn't matter if we plug it into the car or not. I'm just going to use my 12-volt boost box instead of a car battery. It's a lot easier to move around. Actually, my boost box has a 200-watt inverter built right in. So first off, this one was made by Homier Tool Company. They used to do a lot of tool shows around the U.S. Don't see them too often. And I was a moron for not buying more of these. I was young and stupid. 2,000 watt power inverter, $39. No, don't even bother to look. They don't have them anymore. I should have bought every damn one on the shelf. Instead, I bought 10, sold 9 of them and doubled my money. I kept number 10 for myself. It's actually come in handy for a few power outages. But the power coming out of it, I would not plug a laptop in there. It's fine for running your fridge, air conditioning, window air conditioner, some lights. That's about it. This one does have very, very stable, very clean power. Vector is out of, I think they sold out to partially Black & Decker and partially Peak Automotive, if I'm remembering correctly. Now, even though this specific inverter is bulletproof, the tiny ones that just plug into your cigarette outlets on your car were absolutely horrible. I've gone through, well, back 10 years ago, that's all Vector was like the big brand for portable power inverters. I think I must have gone through 4 or 5 of their plug-in ones that go into the cigarette outlets. They literally had the magic smoke come out of them. 2 of them, there's nothing even plugged into it when it let out the magic smoke. All of them were taken care of fairly well. The similar ones that I picked up from Harbor Freight Tools actually have outlasted the Vector ones 20 to 1. Actually, I don't think I've gone through... No, I haven't gone through any of the Harbor Freight ones. They're all still working. But this specific one, bulletproof. I've used this on boats. I've actually left it out in the rain a few times by accident. But anyways, first one, Harbor Freight. I mean, Holier Distribution Tool Company. There we go. No go. Now this is going to be one of your most common problems. We're getting a ground warning. So even though this inverter supposedly has a ground, whatever it is, it's not good enough for the UMC. So that's an automatic rule out. And no, I do not support tampering with inverters. They're very dangerous. You're taking 12 volts DC. It rectifies it up to about 170 volts. Or excuse me, start over. It takes a 12 volt DC, converts it through a DC to DC converter up to about 170 volts, and then rectifies it, inverts it to about 120 volts AC if you're in the US, to something if you're 240 if you're outside the US. If you're outside the US, it takes 12 volt DC, converts it DC to DC up to 340 volts DC if I'm remembering correctly. Then converts it inverts it to 240 AC. I hope you guys could follow that, because I sure as heck couldn't. Alright, so one down. Now, like I said, this one's only 200 watts, so I know we're not going to be able to charge if it works. No ground. Plug it in again. Nope, that one is out of the question. Okay. Alright. Whoops. My bad. Touch the clamps. My bad. There we go. Reset that. Like I said, this little one's been through hell and back. I have to turn this on its side because the plug's a little different here. And what do you know? Now, to tell you guys the truth, I've actually already attempted, even though it doesn't put out enough watts, I did plug it into the car last week, and without charging, the car did recognize it. I did hit the button to start charging at 5 amp, and I instantly blew the fuse on the inverter. So this one does work. Now, you might be wondering, why does it work? Well, let's go over that. And this is also going to somewhat lead up to another video of why you don't backfeed a portable power inverter into your home when your power goes out. And I thank another user, YouTube user, for bringing that to my attention. Alright, so we got our multimeter. I got it set for AC 200 volts. Now, this multimeter is just a cheapie. I don't take out my good one unless it's something important. So these cheapy ones don't read true RMS current. Since this is a modified sine wave, the voltage reading is going to be off. We're reading about 99 to 100 volts, whereas it's actually it's somewhere between 110 and 125 volts. Using a true RMS multimeter would give you the correct voltage reading. It's just these cheap ones don't have the correct circuitry to properly read a modified sine wave compared to a true sine wave. Meter is expecting a true sine wave, not modified. So anyways, alright, got it into hot and neutral. We got voltage. Now watch what happens when I take one of these and put it to ground. Got some voltage. Switch it, take the other one out. Okay, that's nothing. This is actually one of the safer power inverters on the market. But as you can see, there is some bleed over into ground. What usually ends up happening, okay, see 9.1, when I touch that lead to the negative, about 5 volts, a little hard to see. What most of these inverters do, the ground goes to the negative battery clamp on the battery. Some of them are actually designed properly, where the system, it's a little too technical for me to be able to explain. It's a little bit beyond me on how power inverter works. I can tell you the general basics on how they work, but in terms of the technicalities, sorry, it's a little bit beyond my knowledge. But this one, being a higher end unit, this thing was over $100, well over $100. 600 watt compared to 30 something dollars for 2000 watt. This is a very safe inverter. Let's turn off power to it. Get rid of those real quick. Now let me show you what happens. This is a very cheap, very poorly designed inverter. Now, you know, for running a light or a laptop, it'll work just fine. Alright, so we're going to plug this in. Once again, because this is not a true RMS meter, it's not going to give the proper voltage. Okay, you see we have voltage. Now watch what happens when I take this and put it to ground. Oops, sorry, wrong one. $186 volts to ground. Did you guys see that? 186 volts, of course, it's approximate. That is an unsafe power inverter. Once again, not meant for regular use, it's for emergencies. Run some lights, plug in your laptop, it'll work just fine. Safest one in the world? No. And remember that. I want you all to remember that voltage going to ground, because I'm going to do another video why you don't plug a power inverter back into your home grid, and that will explain why you don't do it. Besides the fact that you would blow up the inverter and damage other electronics in your house. Alright, now we're back over to the inverter generator. Let me grab our UMC. So, recap. This inverter, if it had a higher wattage setting, would charge the Model S. Cheap inverter? No. Inverter generator. Ooh, I don't know. Now, even though this is a quieter generator, not silenced, not nearly as quiet as a Honda one. I could film and you could hear me talk if we had the Honda one going. But this one will be a little bit loud, especially on the video. So you will not hear me talk, but I will still show you the lights on the UMC. So let's get her started up. On switch. Oh, choke. Alright, now if you noticed, this one appears to have a proper ground. However, even though it's leaking some of the voltage to the ground, it should work, right? Oh yeah, and you can also, with the generators, you also can ground them to the actual ground. So it grounds the frame of the generator as well. And that frame also goes through to the outlet ground. Now, the reason why this one did not work, even though it is an inverter generator, this one is not, the electronics in that, for lack of better terms, there's a reason why this one was $180 as compared to the Hondas, which are about $1,000 for the 1,000 watt. The electronics in this one don't provide a clean enough output when rectifying it or inverting it, the DC power. This is taking alternating current from an alternator, rectifying it to DC, then re-inverting it back to alternating again. Now, I have already done tests on it, because obviously I don't think anybody wants to stay on my videos for long periods of time, but using some of my other meters, the output is not stable enough, and there is a little bit of, well, actually a lot of what you'd call line noise coming through, which would be my belief is why the UMC will not charge, even though it is giving also the warning flash for ground. So the chances are the ground, for some reason, isn't properly synced up with the rest, with the whole outlet. I'm guessing that ground is more so grounds to the frame of the generator, which would then supposed to be grounded to the real ground. Now, I have tested it grounding it to the real ground, but no matter what I did, I could not get this to work. What you could do is just about all these generators have a 12 volt. And this is about 8. This one will put out about 8 amps on 12 volt. And what you could do is you take your your battery, have the generator outputting its 12 volt system to recharge your battery, and then having a higher end inverter to invert the power clean enough, stable enough to charge your car. And you can actually do that with any generator, because almost every portable generator out there has 12 volt. So even a non-inverter generator, you can just dump it straight into a 12 volt battery and use a higher end inverter to make nice, clean, and quote-unquote grounded power. Now, I wonder what Tesla's going to do about the charging adapters that are going to countries that don't have grounds in every outlet. Lots of Asian countries that I have been to have a two-plug outlet. That's all they got. New construction, old construction, doesn't matter. It's two-plug. 240 or 220 volts output. With no ground, how are you going to charge the car? You'd have to make an adapter that had some sort of external ground. I don't know how they're going to accomplish that, or they might not support those countries at all. If you're stuck somewhere, you're SOL unless you can find some sort of grounded outlet. So there you have it. Stay tuned for my videos coming up on why you don't plug an inverter into your house.